Hi everyone, in this lecture I am going to teach what is super key, how to find out all the super keys from the given relation. For this concept you have to know the attribute closure concept. In previous video I have explained the attribute closure concept. Please check out the previous video once. Now I am going to start today's class. First we will see the definition of super key. What is a super key? What is a super key? Super key is a key whose closure contains all the attributes of a given relation. Super key is a key whose closure contains all the attributes of a given relation. Which attribute closure consists of all the attributes? Then that would be a super key. I will explain with an example. Now I am taking one relation. This relation consists of A, B, C, D, E attributes. I am taking set of functional dependencies. A determines B, B determines C, C determines D, D determines E. So this relation consists of A, B, C, D, E attributes. Functional dependencies are A determines B, B determines C, C determines D, D determines E. So how to find out an attribute or set of attributes is a super key or not? You have to find out the attribute closure. Then only you will know the given attribute is a super key or not. So how to find out the given attribute or set of attribute is a super key or not? You have to find out the attribute closure. You have to find out the attribute closure. Now find out A closure for this functional dependency. So how to find out A closure? A closure itself determines A. A closure itself determines A. Because of reflexive rule, an attribute itself determines an attribute. So A closure itself determines A. Here A determines B, functional dependency is there. So what is the meaning of A determines B? Using A we can determine B. Using A we can determine B. Here we are having A, so we can determine B. We can determine B. Here B determines C, functional dependency is there. Using B we can determine C. Here we are having B, so we can determine C. C determine D, functional dependency is there. Using C we can determine D. Here we are having C, so we can determine D. D determine E, functional dependency is there. Using D we can determine E. Here we are having D, so we can determine E. So what is A closure? A closure consists of A, B, C, D, E attributes. A closure consists of A, B, C, D, E attributes. So what is the definition of super key? Whose closure contains all the attributes of a given relation. Whose closure contains all the attributes of a given relation, then it would be a super key. Here A closure consists of all the attributes. Here A closure consists of all the attributes. So what are the attributes of the given relation? A, B, C, D, E. Here A closure also A, B, C, D, E. Here A closure consists of all the attributes. So A is a super key. A is a super key. Now find out B closure is super key or not. B closure. So B closure itself determines B. Because of reflexive rule, an attribute itself determines that attribute. So B closure determines B. B determines C, functional dependency is there. If you have B, then you can determine C. C determine D, functional dependency is there. If you have C, then you can determine D. D determine E, functional dependency is there. If you have D, then you can determine E. Can I determine A? Can I determine A? So in this we cannot determine A. We cannot determine A. So B closure consists of only B, C, D, E attributes. There is no A attribute. In this B closure consists of B, C, D, E attribute, but there is no A attribute. If B is a super key, then it consists of all the attributes. But here B closure consists of only B, C, D attributes only. There is no A attribute. So B is not a super key. B is not a super key. B is not a super key. Now find out AB closure. Now find out AB closure. So what is AB closure? AB closure itself determines AB. If you have B, then you can determine C. If you have C, then you can determine D. If you have D, then you can determine E. So AB closure consists of all the attributes. Is super key or not? AB is a super key. AB is a super key. If any attribute or set of attributes consists of all the attributes, then it would be a super key, otherwise it is not a super key. This is the way to find out the given attribute or set of attribute is a super key or not. So how to find out attribute or set of attribute is a super key or not? You have to find out the attribute closure. If attribute closure consists of all the attributes, then it will be a super key, otherwise it is not a super key. So this is the process to find out the super key or not. Now find out how to find out all the super keys from the given relation. All the super keys from the given relation. So how to find out all the super keys from the given relation? So I am taking this problem only as an example. For this problem I will find out all the super keys. So how to find out all the super keys from the given relation? Now find out A closure. Now find out A closure. So what is A closure? Just before I explained what is A closure. So what is A closure? A closure consists of A, B, C, D, E. A closure itself determines A. If you have A, then you can determine B. If you have B, then you can determine C. If you have C, then you can determine D. If you have D, then you can determine E. So what is A closure? A closure consists of A, B, C, D, E. Now find out AB closure. Find out AB closure. AB closure itself determines A, B, C, D, E. So AB closure also A, B, C, D, E. Now tell me A is a super key or not? A is a super key. A is a super key. Why? Because A closure consists of all the attributes. A closure consists of all the attributes. So A is a super key. Now tell me AB is a super key or not? AB closure also consists of all the attributes. AB also super key. AB also super key. Now find out B closure. Now find out B closure. B closure consists of B itself determines B. If you have B, then you can determine C. If you have C, then you can determine D. If you have D, then you can determine E. So now tell me B is a super key or not? No, B is not a super key. B is not a super key. So why? Because B closure consists of only B, C, D, E attributes. There is no A. In B closure there is no A. So B is not a super key. So how to find out the total number of super keys? The simple trick is, so what are the attributes? What are the total attributes for the given relation? A, B, C, D, E. So these are the attributes for the given relation. Already I find out A is a super key. A is a super key. If A is a super key, then the combination with remaining attributes would be a super key. If A is a super key, the combination with remaining attributes would be a super key. So what are the combination with remaining attributes? AB, AC, AD, AE, next ABC, ACD, ADE, ABCD. So how many possible combinations are exist? How many possible combinations? 1, 2, 3, 4. Here 4 attributes are there. So 2 power 4 combinations are possible. 2 power 4 combinations are possible. So what is 2 power 4? 16. What is 2 power 4? 16. Now check AB is a super key or not? AB is a super key. A, B, B. If you have B, then you can determine C. If you have C, then you can determine D. If you have D, then you can determine E. Now check AC is a super key or not? AC is a super key. AC, B, D, E. So these all the combinations must be a super key. Why? Because if A is a super key, then the combination with remaining attributes would be a super key. Would be a super key. No need to check again. So how to find out the total number of super keys? If A is a super key, so what are the remaining attributes? B, C, D, E. 4 attributes. So how many possible combinations are? How many possible combinations exist? 2 power 4, that equal to 16. 2 power 4, that equal to 16. So finally, what are the total number of super keys for this problem? what are the total number of super keys for the problem? The number of super keys are 16. The number of super keys are 16. So what are the 16 super keys? These are the possibility of super keys: A, B, A, C, A, D, A, B, C, A, D, E, A, B, C, D, A, D, E. So these are the possible super keys. If A is a super key, only we will get 16 super keys. For example, if B is a super key, in this problem B is not a super key, but for example, if B is a super key, B with remaining attribute combinations would be a super keys. Then we will get more super keys. But in this problem, B is not a super key, so we cannot get any more super keys. Only these 16 super keys are possible for this problem. Only these 16 super keys are possible. Okay, in next session I will explain one more problem. Okay, thank you.